Well, welcome back to this final installment about how to use the law of cosines. And in this discussion, we're going to really focus in on how do we solve application problems using this very handy-dandy law. So let's jump in. So anytime you have an application problem, it probably involves words, which means we need to slow down a bit and actually read the problem. So let's do that. Two sailboats leave a harbor at the same time. One sailboat travels at a bearing of south 12 degrees west at 14 miles per hour. The other sailboat travels on a bearing of north 75 degrees east at 10 miles per hour. How far apart will these sailboats be after 3 hours? Round to the nearest tenth of a mile. Okay, so we've got a couple of sailboats leaving a harbor at the same time, and they're going in different directions, and we want to know how far apart are they after 3 hours. So let's kind of wrap our head around what's actually happening. So let's first identify our harbor. Okay, the harbor is going to be represented at the origin. The first sailboat is leaving the harbor and traveling south 12 degrees west. So 12 degrees off of that south bearing to the west. Okay, here's our sailboat. Next, we have another sailboat that is traveling on a bearing north and then 75 degrees to the east from north. So 75 degrees, a lot, right? So something like that. Okay, and here's our sailboat. Now we are interested in how far apart these two boats are after 3 hours. Now it doesn't look like we have a whole lot of information, but if we look carefully, we really have everything that we need. So let's concentrate first on this first sailboat. We know that it's traveling at 14 miles per hour, okay? And we know that it's traveled for 3 hours. That means for every hour, it's traveled 14 miles, right? 14 miles per 1 hour. So 14 times 3 is going to give us the distance that it has traveled, which is 42 miles. Similarly, when we're talking about this sailboat over here, we know that the boat has traveled 10 miles per hour for 3 hours. So 10 miles for each hour, and there's 3 of those hours, is going to give us about 30 miles. Okay, so we know that this length of our triangle is 42 miles, and this length of our triangle is 30 miles, and we need this. Okay, so if we're applying the law of cosines, we either need that third side. Remember, we use our law of cosines for a side-side-side triangle or a side angle side triangle. Okay, so since this is what we're actually solving for, this is not an SSS case. So we think it might be an SAS case. And indeed it is if we're looking very carefully. All right, so based on the bearings, we're going to be able to find what the measure of this entire angle is. So think about that first bearing. It's 12 degrees off of south, okay? So 12 degrees off of south, that's going to be part of the whole angle. Now, we definitely know what this is, right? Because this is a coordinate plane, so we know that this piece right here is going to be 90 degrees. So we're going to go ahead and add that in. And then that last sliver right here is going to be, this is a little different because we know that this is 75 degrees and we're really looking for this piece. Well, we know that the total is 90 degrees, so I can just subtract that 75 degrees from 90 and get the blue sliver of 15 degrees. And so that entire angle, the angle formed between the first sailboat, the harbor, and the second sailboat, this angle here, can be found by adding those 3 things together, and we find it's 117 degrees. Excellent. Okay, so now I have my side, my angle, my side, and I'm ready to actually calculate this distance. Let's call this distance D, and we can set up our law of cosines because we're solving for d. So d squared will equal a squared plus b squared minus 2ab times the cosine of d. So we can go ahead and substitute 42 in for a, 30 in for b, and those go there as well. And then d will be that angle measure of 117 degrees. So it kind of looks like this when we substitute it all in. All right, and then it's just a matter of using your calculator to calculate this, making sure that your calculator is in degrees because we're taking the cosine of a degree measure. All right, and then we would go ahead and find that we are looking at the distance being the square root of 13,808.06. And then when we take that square root, we get, it's about 61.7 miles. Well, that makes a lot of sense because if we're going 30 miles in this direction and 42 in this direction, if this were a straight line, it would be 72 miles, but it's not quite straight. So it's pretty darn close to that 72. So that's a very logical answer. All right, let's look at the next application. This is a different type of problem. Again, we're going to slow down and read the problem and try to figure out what's going on. Ariel is working on a stained glass art project and she needs to form a triangle with sides 14 centimeters, 12 centimeters, and 8 centimeters. She's creating the triangle out of lead cane to contain the colored glass. Find the measure of the largest angle she needs to create within the triangle and round to the nearest degree. All right, so we have a triangle with those 3 side lengths. So that is great because we know that that means we have an SSS case, right? And SSS is a great candidate for the law of cosines. And what are we being asked to find? We're being asked to find the measure of the largest angle within the triangle. Okay, well, we know the largest angle is going to be opposite the longest side. So we're looking at this angle here. All right, and I know it doesn't line up perfectly, but you get the picture. All right, and so now we just need to apply the law of cosines and solve for that angle measure. Now, if we look at the law of cosines, remember that the angle that we're solving for is going to be opposite the side length opposite here. So this C value here has got to be 14 centimeters, and then A and B can be 8 centimeters and 12 centimeters. So let's go ahead and sub all that in. Oh, looks handy dandy. Excellent. So 14 squared is equal to 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of C. And remember, we're trying to isolate C, so there's a lot of things going on besides just C. So first thing, let's get rid of these constants. Let's subtract them to the other side. So 14 squared minus 8 squared minus 12 squared is equal to negative 2 times 8 times 12 times the cosine of C. Great. Okay, now notice that this is something being multiplied by the cosine of C. So we're going to divide that out. So divide both sides by that, and we would end up with 14 squared minus 8 squared minus 12 squared divided by negative 2 times 8 times 12 is equal to the cosine of C. Great. Remember, we're not really interested in the cosine of C. We're interested in C. So in order to find C, we would isolate it by taking the cosine inverse. The cosine inverse of that whole expression is going to equal C. Now it's just a matter of using our calculator to find what this is equal to. And when we do that, we're going to find that C is about 86 degrees. All right, that wraps up the law of cosines. I'll see you next time.